The biggest mistake people make with thermal cameras is expecting them to replace a conventional security camera. That's not what they were designed to do. Thermal answers one question extremely well. Is something there? It usually doesn't answer the next question. Who is it? I'm Marty. I spec surveillance systems for a living. In the next few minutes, I'll show you what thermal genuinely sees, what it will never see, and how the pros deploy it so those two things work together. A thermal camera doesn't image light at all. It images heat contrast. It isn't seeing temperature directly. It sees differences in apparent infrared energy between objects. A person, a vehicle, an animal. Anything warmer or cooler than the background renders as contrast with no illumination required. That means total darkness. It means headlight glare that would blind a visible camera. And thermal often performs significantly better than visible cameras in light fog, smoke, and dust, because those conditions affect visible light differently than long-wave infrared. Because a warm target pops against a cool background, detection ranges can far exceed what a visible camera achieves at night, though actual performance depends heavily on lens selection, target size, environmental conditions, and the level of detail you need. That's why thermal is the standard tool for perimeters, fence lines, substations, and waterfronts, where the job is knowing someone crossed a line at range in any conditions. So when is it the wrong tool? Anytime the outcome you need is identification. A thermal image has no facial detail, no clothing color, no license plate. A plate is at the same temperature as the bumper it's bolted to. If the deployment needs to answer who was that or what was the plate, thermal alone cannot do it. Full stop. It can't see through glass either. And that includes ordinary architectural glass, acrylic, and polycarbonate. To long-wave infrared, a window behaves close to a mirror, so a thermal camera behind a windshield, a lobby window, or a protective enclosure sees the glazing, not the scene. The answer is pairing. Professional systems rarely ask one camera to do every job. Thermal detects. Visible cameras investigate and identify, often a PTZ queued automatically by the thermal. Here's the field detail that catches people after install. Thermal contrast is dynamic. When everything in the scene approaches the same apparent temperature, the image naturally contains less contrast, and that happens twice a day, typically around dawn and dusk, as surfaces that soaked up or shed heat cross through the temperature of their surroundings. There are atmospheric limits too. Heavy rain, dense fog, high humidity, and atmospheric absorption over long distances all reduce the signal. Thermal handles these far better than a visible camera handles darkness. But it isn't magic, and a detail your installer needs to know. Direct imaging of the sun can damage uncooled thermal detectors. Always follow the manufacturer's installation guidance on sun exposure and mounting orientation. None of these are defects. They're physics. Thermal cameras aren't bothered by changing light, but they are affected by changing environments. Always evaluate the site under the conditions that matter most. On specs, these stay deployment first. Thermal cameras aren't selected by megapixels the way visible cameras are. Lens selection and pixels on target matter far more. Thermal resolutions are much lower than visible cameras, and that's normal, because the job is detection, not detail. What matters is whether the lens puts enough pixels on the target at your distance. Manufacturers publish detection, recognition, and identification ranges per lens, so match those tables to your actual perimeter. Sensitivity, often expressed as NETD, describes how small a temperature difference the sensor can distinguish, and it matters most in those low contrast periods we just covered. A modest thermal camera with the right lens for the distance beats a premium one with the wrong lens every time. When you're not sure, fall back on the questions that outlast every spec sheet. What outcome do you actually need? Detection or identification? How far is the line you're protecting? What are the worst conditions the camera must work in? What happens after detection? Who or what responds? And does the design pair thermal detection with visible assessment? Answer those honestly, and whether thermal belongs in your design and where tends to answer itself. So back to where we started. The best thermal deployment isn't replacing visible cameras. It's giving them the information they need to look in the right place. If you're designing a perimeter, use our buying guides and comparison tools to work through it, or reach out if you'd like another set of eyes on your layout. Links are below. I'm Marty. Build something that actually works.